Welcome to Unit 9, Lesson 1, where we'll be introduced to the graph of a quadratic. Throughout the year, we've learned about different types of functions. In Units 9 and 10, we'll be learning about quadratics. Let's start off with some very important new vocabulary. A polynomial is an algebraic expression consisting of variables, exponents, and coefficients. A specific type of a polynomial is called a quadratic, and this is a polynomial that has the highest exponent being a 2, meaning it's called the second degree. Standard form of a quadratic equation is when you write the quadratic in descending order of degree. So you start with the x squared term, then the x term, and then the constant term. We're going to be paying really close attention to the a, b, and c of this equation, also known as the coefficients. The graph of a quadratic is called a parabola. The parabola is this U shape. A parabola can either open up, as you see in the first graph here, or down, as you see in the second graph. Another important vocabulary term is the vertex of a graph. The vertex is either the highest or lowest point on the graph, depending on how it's opening up or down. The vertex is specifically this point where the graph changes directions. Parabolas have this quality called symmetry, meaning the left half perfectly matches the right half. And this line going down the middle here usually is invisible, but it's known as the axis of symmetry. In a normal graph, we wouldn't necessarily draw this line, but it's drawn here to show you what the line represents. And this is the line that you could fold the graph over, and the two halves of the graph would then be on top of each other. When we're graphing a parabola, it's really important to be able to find the vertex. When you're in standard form, there's a simple formula that can be used to determine the x-coordinate of the vertex. And this formula is x equals negative b divided by 2a. In order to find the y value, well, you just need to plug in the x that you already know for that vertex. So let's get some practice with it with this quadratic. I'm going to start by identifying my a, b, and c values. Now for this formula, I really only need a and b. So we're going to fill in this formula and replace b with that negative 4 and a with that positive 2. Well, a negative 4 is really a positive 4. And 2 times 2 is 4. 4 divided by 4 equals 1, so we end up being able to say that x equals 1. That is the x-coordinate of the vertex. Now this original equation we were given tells you how to find y. It says that y equals 2 times x squared minus 4x plus 8. So we're going to rewrite that, but wherever we saw an x in the original equation, we're going to replace that with 1. And this is going to allow us to solve for y. We start by squaring the 1, so we get y equals 2 times 1, because 1 squared equals 1. Then 4 times 1 equals 4. And now we'll keep following our order of operations and put this 2 and 1 together. And now I'll keep working to the right here. 2 minus 4 is negative 2 plus 8, which ends up giving us y equals 6. Now I did a lot of the work there on my own, but I also could have used Desmos here to either double check my work or do it for me to see that this equals 6. And now this x and y tell me the ordered pair of my vertexes 1, 6. That's going to be really important when we start graphing. Now we're going to be asked on these problems to identify the axis of symmetry. The axis of symmetry is just a vertical line, and all vertical lines are written as x equals a number, and that number is going to be the x-coordinate of all the points on that line. Well, there's a specific relationship between the vertex and the axis of symmetry. Wherever the vertex is, the axis of symmetry is going to go through that point. So the x-coordinate of the vertex is going to match the number that goes with this axis of symmetry line. So when you know the vertex and you know its x-coordinate, that's going to tell you the axis of symmetry formula. It's just going to be x equals that x-coordinate number. So the axis of symmetry for the parabola that has a vertex of 3, 2 is just 3. X equals 3. Now, as we mentioned earlier, a parabola can open down or open up. And this all has to do with a, the leading coefficient. If it's positive, the graph will open up. If it's negative, it'll open down. So we're asked, is this equation going to open up or down? Here's our a, negative 3. And since that's negative, we're going to open down. It's as simple as that. Positive leading coefficients mean open up. Negative leading coefficients mean open down. Now here's a written explanation of the steps we're going to follow to graph from standard form, but I'm just going to show you with a problem. So all the problems are going to look kind of like this. There's going to be a space here to make a table for the points that you're going to use to graph. There's obviously going to be the space to graph. They're going to ask us whether the graph opens up or down. what the axis of symmetry is, what the vertex is, and whether or not the vertex is a max or a min. You don't necessarily need to follow this order. My first step would always be to find the vertex. In order to find the vertex, I'm going to identify my a and my b. That's really what I need. And I'm going to use the formula x equals negative b over 2a. So pulling the 1 from a and the negative 4 from b, I get x equals negative negative 4 or positive 4 over 2 times 1, 2. That gives me x equals 2. That is the x coordinate of my vertex, which also happens to be the axis of symmetry. Remember, whatever the x coordinate is our axis of symmetry. Now our y coordinate is going to be found by plugging that x into this equation. Now doing some simplifying, I get y equals 4 minus 8 minus 3, or y equals negative 7. So now I know the x and y coordinates of my vertex, and we can even graph that point. I go 2 to the right on the x-axis and 7 down on the y-axis, and I graph this point right here. Now, because our leading coefficient was positive, we know that this graph's going to open up. So we're going to start generating some points in a minute, and we better see this shape go upward. I'm going to put a little dotted line through that vertex to remind us of our axis of symmetry. And now we're going to come over to our table and start getting some ordered pairs. The middle of our table should be the vertex of 2, negative 7. It's in the middle of the graph that we're going to end up drawing, so it goes in the middle of our table. Now from here, I like to do something that I call drawing the coffee mug. So I go around my table and I draw the handle of the mug. You're going to see why in a minute that this is helpful. Now inside the table, I know 2 is the middle, and all I'm going to do is put 2 numbers bigger than 2, 3 and 4, the next 2 numbers. And below 2, I'm just going to go backwards going up. I'm going to go 1 and 0. We don't need to overthink this. We're just going to pick the 2 bigger and 2 smaller numbers around 2, whatever the vertex x is. Now, just like we did to find the y coordinate of the vertex, we need to find the y coordinates that go with these x's. I'm going to start with the y that goes with 0 because I think 0 is going to be pretty easy to plug in. I'm going to rewrite my equation from up here, but I'm leaving spaces to plug in the x, which in this case is going to be 0. Now, like I said, this is going to be pretty easy to compute because 0 squared equals 0, 4 times 0 equals 0, and then we've got that negative 3. So this gives us y equals negative 3, which we're going to put here. Now here's where the coffee mug comes in. This outside part of the handle is telling us that these 2 x's should have the same y because they're equal distances away from the vertex, and symmetry says they should have the same height. If you just look at the graph, 0, negative 3 is right here. If I were to fold the graph over this axis of symmetry, there should be another point the same distance away from the vertex at the same height. And that's what this 4 is. That 4 is going to have a height of negative 3. So when we calculated 1y, we actually ended up getting 2 y's. And these 2 points are something we call a symmetric pair. Now we're going to do the same thing again to find one of these 2 numbers. I think 1 will be easier. So once again, I rewrite this top equation, leaving spaces to replace the x's. In this case, I'm replacing them with 1, and I get y equals 1 minus 4 minus 3, or y equals negative 6. And now that negative 6 is going to go with 1, and we're going to follow the inside handle of the coffee mug to know that a negative 6 goes here as well. So now we're going to get the symmetric pair of 1, negative 6 and 3, negative 6. And you see I'm starting to follow that U shape. As you can tell, our vertex is the minimum point on this graph, as it's at the bottom of the graph. Any graph that opens up has a vertex that's a minimum. A graph that opens down would have a vertex that's a maximum. And now all we have to do to finish off this problem is just draw our U. And we've completed the graph for this problem. All right, let's take a look at one more example. In this problem, the leading coefficient's negative. So right away we know that this is going to open down. And since a graph that opens down looks like this, the vertex is going to be the max, since that's the highest point on the graph. Now remember, the axis of symmetry is really just the x-coordinate of the vertex here. And that formula is negative b over 2a. And our a is negative 2, our b is 12, and our c is negative 13. So this formula is going to say negative 12 over 2 times negative 2, or negative 12 over negative 4, which gives us x equals 3. So that's the x-coordinate of our vertex and the axis of symmetry. I'm going to sketch a dotted line to represent that axis of symmetry. And now we need to go find the y-coordinate. And to find that y-coordinate, what we need to do is we need to write out our equation and replace the x's with 3. And Desmos tells us that that means y equals 5. So now we know our vertex and we can start building our table. The vertex is going to go right in the middle of that table, and then I'm going to draw my coffee mug. The x's that I'm going to use to fill out that table are 4 and 5, and going backwards, 2 and 1. I can also go and put that 3, 5 vertex point on the graph, and now I'm going to go try to find the y's. And to do that, I'm going to pick some of these x's and plug them back into this original equation. Remember, I'm just replacing the x from the equation with whatever the x is that I'm plugging in. That's how I go find the y's. So let's do that with 1 to find this y. And I go to Desmos again to see that that's -3. So now that I know the y that goes with 1, I'm going to follow the coffee mug down to the bottom and put that symmetric pair as well. So whenever you get 1 y, you get 2 y's. Then I'm going to go graph those points on the graph. Now let's go get our final y. And now I can pick either of these remaining 2 x's, and I'm just going to go with the smaller one, 2. And one last time I'm going to go to Desmos to see that the y is 3. And I'll take that 3 and put it into the table. It goes with both the 2 and the symmetric pair 4, and we'll graph those points. Now that I've got my 5 points graphed, I'll just go through and draw my u. And this graph is finished, meaning that this problem's over. All right, let's sum up this lesson. Standard form graphing means find the x using the formula, plug it back into the original equation to find y, then pick 4 x's around the vertex, and use that coffee mug for symmetry as you find each of the remaining y's. If you came away with anything else, write that down now. Otherwise, we'll see you in the next lesson.